Okay, we're live. All right, so anybody have any questions before we start going through the part one?
No, I don't have any questions part one, but once we get to part two, I have a question.
Okay. All right, we'll go through part one then. So the first question was, what is the sampling distribution? What did everyone get?
Basically the set of all the sample means from a population.
Ditto.
Yep, from a specific population, yep.
That's just that U thing with the bar X, right?
Mm.
Yep.
Okay, number two, what is the shape of the sampling distribution of the sample mean when the data are normally distributed?
Normal.
Normal. Yep.
I first put bell shape and I thought, oh, that's wrong. It's normal, right? It's not bell shape. Right?
Yeah.
Yeah.
Okay, number three, what is the shape of the distribution of sample means when the data are normally distributed, but the sample size is large?
Approximately normal.
Yeah.
No.
Yep, that's what I got. Okay, four, how does the shape of the distribution of sample means change when the sample size is increased?
Put the shape approaches normal condition decreases and the mean is unchanged.
Yep.
Yep.
Yeah, the mean is unchanged. Yep. Okay, number five, what is the difference between the central limit theorem and the law of large numbers? So the central limit theorem is, what is it? Gives certain conditions the arithmetic mean of a certain specific. No, is that the wait?
Right, like the difference of central limit theorem and the law of large numbers.
Okay. So yeah, the central limit theorem states that the sample size is large. The sample mean will be approximately normal number 4. And then the law of large numbers states that the sample size increases, the standard deviation of the sample mean will also get smaller.
Mm-hmm.
Right.
Mm-hmm.
And they population mean. It seems like they threw in the word population, but I wasn't looking. It's just the mean. Mean.
I think population is just referring to, I guess, the sample of what you're.
That's what I thought. I just thought it was odd to start calling it population, but I thought that just means the sample. Okay.
I mean, I think yeah, maybe better would be maybe something like sample, just because I mean it's not always referring to people that we're doing the studies on, or you know. So. Okay, now the last part of. Are we okay to move on to question 6?
Yeah.
Yeah, I'm good.
Well, there's kind of that
So
other
when-
part of the large. It says as the number of repetitions increases, the proportion of the outcome probability of the outcome squishes
Garth,
back.
I can't hear you very well. I don't know if you can.
No, that's a technique. Is that better now?
Yeah, I
Yeah,
can hear you.
Yeah.
Okay. All right, very good.
So what was your question again, Garth? Or what were you saying?
Well, the law of
Put it away.
that large number of repetitions increase in the experiment, the proportion of the outcome closer to the probability of the outcome. I remember that graph, it just kind of squishes down to eventually roll the dice long enough, we're going to come out 50-50.
Yep.
I think that's okay. Okay.
So, pretty much what you're saying, just less words. Yeah, the law of large numbers. The more sample size you have, the more closer the standard deviation of the means, the means of the means, I guess you could say, that's going to be a lot smaller when you have a larger sample size.
Yeah. Certainly, accuracy would increase.
And then for number 6, when is Rx normally distributed?
And then the 2 straight from the textbook is will be normally distributed if the data were drawn from a normal population. And then the second one is will be approximately normal distributed if the sample size is sufficiently large.
And then they say that
Right.
the sufficiently large is like approximately 30. Is that what they said?
Yeah, I think it was over 30. Yeah.
Cool.
However, it said if it's 30, it's large. 100, but 30 is good.
Okay, no one got anything else, right? So we'll just move to part 2 then.
Mhm.
Yeah.
Okay. Daniel, did you want to ask that question right now, or is it on a specific question?
It's gonna be like the very last one, like question 8D, the
Okay.
standard deviation. So when we get there, I'll bring it up.
Okay. Okay, so first one is number 7. Randomly select 5 of the 30 salaries and compute the mean. So each of ours will be different, but I mean for A, what is the mean of your sample? I got 50,000. What'd you guys get?
I got 44,480.
I got 45,140.
Okay, and you, Garth?
60.
Okay.
Yeah.
And then was it B? B, I think is just showing the graph. It's C, it says, does your sample mean appear to be unusual? Explain why you think it is or not.
Well, it sounded like none of ours were unusual because the way that statistics says unusual is if it's beyond the 2 standards deviation. So if it's like beyond -2 or beyond 2, then it's unusual.
Mm-hmm.
I know mine was it was at 50,000, so it was close to 2, but it was still usual. So yeah.
Yeah.
Yeah, thank you. Don't go mama.
But yeah, everyone else is just usual. So
I think that pretty much takes care of 7D too. So just go to 8.
yeah. Okay, so the graduate management admission test, GMAT is used as an admission criterion in many master's or business administration and MBA programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a written random sample SRS of 10 students taking the GMAT. So A, what is the shape of the distribution of the sample mean for all such samples?
And it's like bell shape, right? Or like normal.
It's normally
Yeah, though, yeah, that's normal distributed.
And the reason it's normal is because it says in the normally distributed.
Yep. And then from the, so B then is how do you know that the distribution of the sample mean has this shape? From the central limit theorem, we know that the parent population is normally distributed as well.
Yeah.
Yes.
The population is normally distributed.
Okay. And because of B, we can answer C as well. Then what is the mean of the sampling distribution of sample mean scores for all such samples? Then we can get, I got 529.
Yeah, it's just 529.
Yeah.
And then D, the last one.
Yeah.
What do you-
How do you calculate this? That's the one thing I'm always confused with is from the information
Yeah.
given, how do you get the standard deviation that they want?
So you do 113 divided by the square root of 10.
Okay. Okay, so it's the little o, so the standard deviation over square root of n.
The number, the sample number, yeah. Mm-hmm.
Okay.
And that
Comes out.
will get you the 35.73. Yeah, I had to play around with it because I mean it's not really straightforward in the book because I tried a whole bunch of different combinations before I figured it out. So
Awesome.
Are
there any other questions though?
No, that was my only concern. What was that formula?
Yeah. Matt or Garth, do you have any questions, or should we just move on to the quiz now?
I'm all good. We can
Well,
go.
the only thing I had with D was that I'm assuming that we continue to carry those out to 3 places.
Oh yeah. So the answer would be
Because you got to use the whole stinking square root of 10 thing, which is 3.162277766. It's huge. But that
Yeah.
gives it.
yes.
You can do the quiz. Pull it up.
So the answer